All right, good afternoon, guys. So today we worked on domain and range, and there were a couple people on the struggle bus today. So what I wanted to do was do a few of these cards that are not necessarily in your packet, to maybe try to get you some extra help on that. So give me just a second, let me get a pen, and we will do some extra stuff on that. So let's see. I'm feeling blue today. We'll do a blue pen. Okay. So I think, I'm not sure where a lot of the struggle is, but there's a struggle on domain and range every year. And while my hope was that the foldable would help you see kind of that domain spreads across the x-axis, so the two edges of your foldable should line up with the edges of where your function spreads through, and same with your range. Your range is what it spreads through on the y-axis, so it would measure kind of how far it spreads on the y. So we'll do that. We'll do a few of these. So if you are in my class, you should have gotten all of your cards. So you can do this along with me with your foldable and with your cards. So if you'd like to do that, go ahead, pause the video, and grab your stuff, and then we'll hit play from there. All right, so I'm going to start with card 31. I think it's important to start with one that is not necessarily discrete, and important to start with one that is linear. I think linear is good. I don't know. I just think linear is a good place to start. So we'll just start with a linear one. So in order to use, if you're struggling with how do I use this foldable, you're going to want to stick your card in the middle, like where, if you're in my class, you have the little sheep and the little Bitmoji. If you are in Miss Means' class, or if you're like just in the world watching a video, you probably don't have this at all. But yeah, so if you have the foldable, if you're in my class, it'll have these little markings. You're going to stick your card in here. And the first thing we're going to look at is the domain. So remember, the domain is the set of all possible x values of your function. So actually, I'm going to scoot this over. We're going to write that down. The domain is the set of all possible x values for that function. And so technically, maybe function is not the right word. Maybe we should say relation, because you can do the domain of a relation that doesn't happen to be a function. So yeah, let me correct that. So it's all the possible x values for that relation. That does not mean everything on the x-axis and everything on the y-axis, because remember, I can expand my x and y however far out I want to. This is not the end of my x and y coordinate plane. This is just what I chose to graph on. I could extend this out 200 boxes, and this one out 200 boxes, and this one out 200, and this one out 200, and it'd be a pain in the butt, and I'm not going to do that. But you can do that. That's why we don't want to just list everything on the x and y axis. Have I seen that problem this year? No. Did I see it last year? Yes. So maybe there's not a reason for me to warn you guys about that, but I've seen it before, and I feel like if I tell you about it now, maybe you won't make that mistake. Okay, so my domain is all possible x values for this function. So we're going to spread our foldable out. I want to know what x values this function could possibly touch. So for those of you struggling to use this foldable, I think the easiest thing to do is line this up so that all you see is the y-axis. And we're going to spread these little flaps out. We're spreading them out and running them along the x-axis. And we're going to stop until we reach an endpoint or an arrowhead, or I don't even want to say an endpoint or an arrowhead. We're going to stop until, we're going to spread these out until we don't have a function anymore, or we don't have a relation anymore, once we're out of data. So if I look, my data ends here. Okay, So my data ends here, but it doesn't necessarily end. It's got an arrowhead, which means it continues on. So this is going to keep going and going and going. I just don't have the room for it, guys. I can't draw a line forever. I'll never finish it. So this is going to keep going and going and going and going and going all the way to positive infinity. And then in this direction, it's going to keep going and going and going and going and going all the way to negative infinity. So it goes from negative to positive infinity, which means every single conceivable number out there is in the domain. There is no limit to the numbers I can put in my domain. So for this example, for card number 31, my domain is all real values of x such that, or values of x such that x is all real numbers. I feel like I am butchering how to say that. I'm going to have to double check. Because I know if it's not all real numbers, you say values of x, but I'm not sure in this case. But anyway, all my values of x are all real numbers. I think that's the easiest way to put that. So let's look at the range. All right, so I'm going to look at my range. I'm going to cover it up so that all I see is the x-axis. And then I'm going to spread these out until I don't have any, until I can see my entire function or my entire relation. Okay, so I'm going to look here. And I've got an arrowhead, which means that going in this direction, I'm going to continue to go. My function is going to continue and continue and continue all the way up to positive infinity. And headed downward, it's got an arrowhead, so it's going to continue to go and go and go all the way down to negative infinity. All right, so I go from positive infinity to negative infinity. Again, it's the exact same thing. It's going to be all real numbers. All right. Okay, so this is an easy one because it's linear and it doesn't have endpoints. So since it doesn't have an endpoint, it doesn't stop. So of course it's going to be all real numbers because it goes on forever. So let's find one. Let me see. Let me flip through these and find one that. Ooh. Let's look at number 30. Number 30 is an interesting one. So number 30, it kind of has this, I don't know what shape to call that, like maybe a sideways J or something. Y'all, I grew up in the country, so I'm like, that looks like a BB gun to me. I hope I don't get arrested for saying that or anything, but like it's got a curve to it. So, let's look at this one. So we're going to do the same thing. Let's find the domain. Domain's all possible x values. So we're going to spread this out till we can't see any more of the functions. So there's the arrowhead. And then here is my endpoint right here. So my domain, if I look, of course, we already said, oh, it's got an arrowhead. So it's going to go on and on and on forever. So this one goes on forever in the positive direction, but not in the negative direction. Like you see, it ends right here. It doesn't continue. So I have to figure out at what point does this end. So I'm going to look and find the x coordinate that corresponds with this. I saw a lot of people struggling today to remember their x and y coordinates. So you remember you start at 0, 0. X is the horizontal axis. If you go to the right, you're going in the positive direction, just like a number line. And if you go to the left, you're going to the negative direction. So I'm going to count 1, 2, 3, 4, 5. So that is 5 spaces away from the origin on the negative side. So that means that my in upper maths we call it our bounds, like our boundary. So let's call it our boundary. We have a boundary at -5. So if I look, my function starts at -5 and goes to the positive side, but it doesn't end at the positive side, so it goes on and on forever. So we have to think, is -5 the smallest x value or the largest x value I have? And since I'm traveling from negative to positive, this is going to be the smallest x value I have. So my domain here on number 30, we're going to say that x, it's all values of x such that x is greater than or equal to -5. So all my x values, my lowest x value is going to be at -5, and it's going to increase in the positive direction forever and ever and ever. So it's every x that's greater than or equal to -5. Okay, so then let's do range. So all we're going to see on our range is our x-axis. We're going to spread it out. Now I don't have to spread the top one out because I've kind of got a boundary right there. And I'm going to look here. And that's about as far as it goes. So on my lowest y value, let's count and see where we start from. So we count and we go down 1, 2, 3, 4, 5. So again, we start at -5 again. But what happens here? It almost levels out. We have not gotten into this terminology yet. In this case, what's happening is we are getting infinitely closer to the x-axis, but we're never actually going to touch it. The x-axis in this case is called an asymptote. Again, that's something that we have not discussed, but basically what that means is that we're going to get close and close and close to this x-axis, but never actually touch it. So the lowest y value I have is -5. And we're getting infinitely closer to the x-axis, and the y value for the x-axis is 0. So we're getting close to 0, but we're not touching it. So this is an interesting one. So my range is that the lowest value we have is -5 for y. And the highest value, we don't actually get to 0, but we get pretty darn close. So what we're going to say is that -5 is less than or equal to y, but y is less than 0, because we don't actually ever touch 0. So the graph on my y values, we touch -5, we have a value at -5, and this one we're getting really, really close to 0, but it's kind of leveling out, so it's never actually going to touch 0. So we will do just that y is less than 0. So just so you can see the domain and the range again. I'll leave that up there for a second. I think I'm going to do one more example. I'm going to flip through and find me a really, really good one to do. I'm trying to do stuff that I know is not on your homework assignment or in the assignment I gave you. Okay, we'll do this one. Actually, no. Not that one. Change my mind. Let's do 27. 27 is an odd-shaped one. 27 is going to be one of those that looks really strange, but it's going to be straightforward. So again, let me smooth my stuff out because I keep pressing down on them and they're creasing up. Okay, so domain. We'll do our domain flaps. We will make sure we get to include all of our function. All right, so let's look for the leftmost value for x, and that would be this point. So I'm going to count away from the y-axis. That is 1, 2, 3, 4 away. So that is at -4. And then I'm going to look at the point that's on the right, like the most to the right. 1, 2, 3, 4. So we go from -4 to +4. So for number 27, my domain is that x is between -4 and +4. So the best way to write this, remember, x is between these two. So that means that x is greater than -4, but x is less than +4. I mean, it can be equal to, but a lot of people get confused on which way to write their alligator mouth. So remember, x is bigger than this one and smaller than this one. And if you write these in the correct order, these should be less than signs. As long as they're written in like numerical order, they'll be less than signs. Okay, and so my range, we'll go ahead and set this up. My range. So we're going to do the same thing that we just did. Okay, so I'm going to count to my lowest range value, which should be down here. This is the lowest. And if I count from the origin, I go down 1, 2, 3, 4 spots again. So we, again, start at -4, and my highest range value is at 1. So my lowest is at -4, and my highest is at 1. So we go from -4 to 1. So y is between -4 and 1. All right, guys, I really hope this video was helpful for you. Domain and range is so important. I am going to ask you questions on almost every single quiz about domain and range. I don't say that to scare you. I say that to stress the importance of this lesson. So I hope this was helpful. I hope if you were struggling, you thought to check the Google Classroom videos. If there's anything else you need from me, just shoot me an email. And I'm noticing people are kind of liking the videos. I am sorry they take so long. Like, y'all know Miss Gallant. Miss Gallant's long-winded. She can't help it. But I just want to make sure everybody gets all the information they need. So I do apologize if these are way too... Well, actually, you know what? No, I don't apologize if they're too long. I'm taking time out of my day to help you too. So I'm not going to apologize for them being wrong. But I am glad that you're watching. And thank you for always doing what you're supposed to do. If you need anything, you feel free to shoot me an email. And I hope you have a good evening.